Okay, here's our video today on buoyancy. And in simple terms, buoyancy is the force that helps things float. Except for this ship in the background there, right? So we'll talk about why ships float. So let's write that down. So buoyancy is the force that helps things float. And there's two concepts we'll deal with. We'll talk about an equation, and we'll talk about why ships float, giant steel ships. But we should talk about density. We know that if it's less dense, it will float. Like oil is less dense than water, and so is rubber, like your rubber ducky. And we'll also talk about displacement. And displacement, we'll go back in time. We'll go back to Archimedes in ancient Greece. And you can see these barrels in the water. We don't know what they're filled with, but they're perhaps filled with air, because air is less dense than water. And that is a big reason why ships, except for this one, float, is because they're full of air. Hot air. Not hot air, but. So the legend goes, for Archimedes, great inventor, engineer of ancient Greece, when he was sitting in his tub, and he was sitting in, whether this is true or not, and he saw that the water rose, and he had that eureka moment. That's the principle, the Archimedes principle of displacement. So let's say we had a container and it was full of water. And maybe we'll make the water green today. Green water. And if we put in a object, let's say a rock, the rock submerges in the water. And then what would happen is it's going to displace water. The water, the green, will rise. It will rise based on the volume of the rock. So that's what Archimedes found out. The water rose. It was displaced. So the rock is pushing down on the water, and the water is pushing up. So we have to talk about Newton. Right? Newton's third law. Newton's third law. Right? And Newton's third law says for every action, there is an equal and opposite reaction. So as the rock pushes down, gravity is pushing down, and of course, what do you think is pushing up? Buoyancy. Simple as that. So for a ship to float, it first of all, the ship is displacing water, but it has to be less dense than water. And it's all that air in the ship that's going to help it become less dense. The buoyancy force has to be greater or equal to the weight of the boat. If it's not, the boat will sink. Let's clear this out. Make a boat. Right. So if we made a green boat, this giant boat, the shape of the boat matters. The shape matters. The shape has to be designed so the boat can displace a volume of water. So as it goes down in here, the boat is filled with air. They have to be designed where they're filled with air. And there's a lot of air on that ship, and that air is less dense than water, and that's one reason why the ship floats. So in simple terms here, for a ship to float, the buoyancy force, again the force pushing up, gravity's pushing down, the buoyancy force must be equal to the weight of the ship, or greater. If it's not equal, or if it's less than the weight of the ship, then the boat will sink. Let's write that down, make sure we understand that. Right over here. For a ship, or boat, whatever you want to call it, for a ship to float, capital F, for a ship to float, the buoyancy force, the buoyant force, must be equal or greater than the weight of the ship. Keep that there for a minute. And the design of the ship, like I said, is very important. The design of the ship is very important. It's designed to displace enough water. All that water, remember, displacement. As it goes into the water, it's displacing water. Water is rising. And that displacement has to displace enough water to create a buoyancy force that counteracts the weight. In other words, that's equal or greater than that weight. So in other words, like when you put a ship in water, when it's placed in water, it's going to push water out of the way. The rock pushed water out of the way. Anytime you put something in water, and if it's denser than water, it's pushing water out of the way. So the ship, the way it's designed, it's pushing water out of the way, displacing it. And the weight of the water displaced creates an upward buoyant force. Again, like I'll say this again, as long as the buoyant force is greater than or equal to the weight of the ship will float. Now let's look at Archimedes' principle. Let's clear this out. Clear it out. Maybe we'll keep this. Let's do yellow. It's all right over here. Archimedes' principle. And here's the equation. So we have this little subscript b there, and that's the buoyancy force. And it's going to equal this p. P is for density, by the way. And we'll say fluid. So again, that's just the density of water. This is the density of water. And we're going to times it by what's displaced. And that's the volume of the fluid that's displaced by the ship. So this, again, is the water. The density of water. Remember, the P is for the density of water. And this is, okay, V is volume. The volume of the fluid, in this case of the water, displaced. So it looks like some fancy equation over here. And also, we also have to times it by this g, and g is the acceleration due to gravity, which is approximately, we'll say over here, 9.81 meters per second squared. So that is, we'll do an example. Let's do an example of that. Of course, to do an example, we need to know the weight of the ship. And we need to know the weight of the ship in newtons, which I'll explain. So let's look at an example. Let's just look at any, let's say a boat, a small boat. Let's say a boat is 200 kilograms, small boat. We want to put it in newtons first. So to get the weight in newtons, you just got to take the 200 kilograms of the small boat and times it by the acceleration due to gravity, which is 9.81 meters per second squared, right? And if we do that, the weight of the boat is going to be approximately 1962 newtons. So keep that in mind. We have 1962 newtons. That's the weight of the boat. Now let's look at the formula. And let's use another color so we don't get too confused here. Maybe red or orange. So the weight of water is approximately, by the way, the density of water, not the weight. The density of water is approximately 1,000 kilograms per meter cubed. And we know that the weight is 1,962 newtons. So let's rearrange this. And over here, this is the buoyant force we're going to set equal to the weight of the boat. So we know it's 1,962 newtons. Now let's say we want to find what is the volume displaced. We can rearrange the equation, right, by dividing this and the gravity on one side, and we'll get what the volume is displaced. So let me make room here. I'll clear some things out. So we'll just get my pen working again. Just cleared all that out. So we're going to say, and we need a pen, right? There we go. So we're going to say that, again, let's rewrite the formula here. We have that, the density of the fluid, the water, times the volume that's displaced, which we're going to try to find, times g, the gravitational acceleration. So we can rearrange this, right? We said that the weight of the buoyant force weight is the weight of the boat, which we said was 1,962 newtons. The weight of water, we said, was 1,000 kilograms per meters cubed. We're trying to find the volume displaced, and we know that the gravity acceleration is 9.81. We'll just keep those in there. And we'll rearrange this because we're trying to find this. So we'll divide everything on one side here. We can divide this over here. We'll just use another color. So we'll get 1962 divided by 1,000 times 9.81. And that will give us the volume displaced. Forgot the D. Put the D there. So when we put all this in, and you'll get 0.2 meters cubed of water that is displaced. And that's the Archimedes principle. Now, just to review here, we know that ships float because the majority, even with all the cargo, they're designed with all that cargo and all that metal and all that machinery, they're designed because of their shape to have a lot of air. And all that air is less dense than water. And also we know that the buoyancy force that helps things float is greater or equal to the weight of the ship. It has to be, because if it's less than, it will sink. And so boats that are not designed right or have too much cargo will sink. So that's the buoyancy force.